Okay, good morning again, guys. Today we're just going to have examples. Medyo nabilisan ko yung part nung conductors last time kasi kapos na sa oras. So, ayan, talakayin natin ulit sila. Okay, and then, yeah, bibigyan ang prob set. Gauss's law examples. Start tayo, may dalawa tayong example. Dalawa lang. Sorry guys, pagod talaga ako. Ayan, nasa libro naman to lahat. I mean, yung mga tanong nasa libro. So if you want to redo them, you're free to do that. Okay, so yung mga bagay dito, yung mga tanong would have conductors. And again, conductors ay E. Electric field is 0 inside it. Okay. So, ibig sabihin ng inside niya would be on the thickness of the conductor. Okay? And then, what else? Charges reside on its surface. Okay? Okay, so let's try to do things. You see this infinitely long cylindrical conductor has radius r and uniform surface charge density. Okay, kung mapansin nyo, gumamit siya ng uniform surface charge density. Okay? Kung insulator to, baka gumamit siya ng uniform volume charge density. Okay? So since this is a conductor, yung surface niya lang yung pwede magkaroon ng charge. Therefore, gagamit siya ng uniform surface charge density. Pero pwede rin siya gumamit ng line density. Okay. Anyway, ayan. In terms of sigma and R, what is the charge per unit length? Ayan, sinasabi ko pa lang. For the cylinder. Okay, so drawing muna tayo ng cylinder. Okay, so may mahaba ka raw na cylinder. Sige, lakihan natin para... Okay, so may cylinder ka na ganyan. Tapos, it is of radius R. Then, sprinkled. May sprinkled on its surface would be sigma. Okay? So, it has some sigma. And then yung tinatanong would be charge per unit length. So lambda is charge per length. So kung imagine natin, di ba may, kung yung kabuuan yung titignan mo, this would have a Q, charge Q. And then Q per L, that would be, kung imagine nyo, would be this little strip here. Yes. Yeah. That would be this little strip here. Okay? Gets ba kung bakit ayan yung lambda? Diba kasi yung kabuuan would be Q. Then if you divide it by the length, yung makuha mo would be this strip. Okay? However, sinasabi sa atin, tinatanong sa atin, what would be that lambda in terms of sigma and R? Okay? So yung sigma mo would be, sulat natin dito, sigma, kung imagine naman, ay sorry, lambda pala yan. Sigma is Q per area. Tama ba? And what is that? Kung imagine natin yun, ang itsura niya sa cylinder natin would be some square. Okay? Kasi per area. Therefore, inside this lambda, meron kang maliliit na squares, which would be sigma. Okay? So sigma to, this is sigma. This is another sigma. Okay. So para maging equal tong sigma and lambda, you'd see that lambda must be equal to, bubuuin ko lang si sigma along this strip. Di ba, pabilog to, nakatuloy pa yan sa likod. Okay. So kung bubuuin ko si sigma, I would just multiply it by the circumference. 2 pi r ang circumference, tama. 2 pi r, then times sigma. So this is my lambda in terms of sigma and r. Okay, so we're done with A. Okay, next would be in terms of sigma again. What is the magnitude of the electric field produced by this charge cylinder at a distance r greater than r from its axis? Okay, so the tanong lang sa atin would be the electric field produced by this cylinder. And of course, dahil may symmetry yung system, cylinder siya, sphere, or whatever, magagamitan mo ng Gauss's law. Okay? So, kapag may cylinder kang object, gagamitan mo lang din siya ng Gaussian surface ng cylinder. So, isip ka ng cylinder, imaginary cylinder around here. Okay? Of variable radius r. Okay, kasi kahit gano'n kalaki yung Gaussian cylinder mo, Gaussian surface mo. Okay, so by the Gauss's law, E times the Gaussian surface, which is scratch ko. 2 pi r L. Okay, yung L niya would be some length. Okay. Some length. And then that must be equal to the charge enclosed sa numerator, tapos denominator would be epsilon naught. Okay, so we have to think kung ano yung charge enclosed. Okay, so this guy, ito yung Gaussian surface mo. Titignan mo lang kung gaano karaming charge yun nasa loob niya. We can use lambda. Okay, since lambda is charge per unit length, tapos naka-length din naman tayo, mas madaling gamitin yan. So therefore, charge per unit length times length would be charge. So ayun yung charge na may enclose mo. However, tinatanong sa atin, what would be the field in terms of sigma? So with this, papalitan mo lang si lambda ng sigma mo in terms of sigma. So you switch it to there. So this is 2 pi r L over 2 pi r L sigma over epsilon naught. Now we can extract E. So that would be 2 pi r sigma L 2 pi r L epsilon naught. 2 pi cancels out, L cancels out. We are left with sigma r epsilon naught small r. And then if we're gonna have it to be a vector, that would be on the direction of r hat. Okay? Okay. Marami nalilito dito, no? Yung capital R is a constant, so you can't use that in terms of I mean, nilalagay kasi nila minsan sa unit vector, sa direction. Okay, so yung variable yung gagawin mong direction. And the variable is the Gaussian surface. Okay, next. Okay, express your result of part B. Okay, may sa part B. In terms of lambda. And show that the electric field outside the cylinder is the same as if all the charge were on the axis. Okay. Sabi niya, gawin daw muna nating dilipat ulit natin to sa lambda. Pakahirap tayo. So we just write this down as lambda over 2 pi r. Then I plug it in here. Therefore, I could have lambda r over 2 pi capital R epsilon naught. Then the small r, cancel the big R. And we are left with lambda 2 pi epsilon r hat. Okay. Ito na yung sagot. Explain mo na lang bakit nga ba bukang yung electric field it's coming from the axis. Ang clue niya would be compare your result to the result for the line charge. Okay, so tinry natin yung line charge kahapon, I think. Okay. Ayun, ito. Electric charge distributed. Okay, ito na yung infinite long thin wire. And tinry na natin to. Ito yung sagot. Okay. Very similar to dun sa atin. Sagot natin. Kasi lambda over 2 pi s. Pero r lang ginamit natin ngayon kasi ayun yung sinabi nung tanong. Okay. Ayan. Sinabi kasi sa tanong, gamitin mo si r from its axis. So no need na mag-transform ka dun sa sinabi kong coordinate system na may s. Okay? So define naman na yung r na galing siya from its axis. Okay? Ayan. Nasagot mo na yung yung part na to. Kasi yung sagot natin, kamukha nung infinitely long wire. Diba? So, it would seem that sa mga ganito, it's as if na yung charge were on its axis. Okay? Okay, let's have another one. Again, meron tayong conducting sphere. A solid conducting sphere with radius r carries positive charge q is concentric with a very thin insulating shell of radius 2r. So, meron kang gawin natin. Meron kang solid. Then, meron kang concentric sa kanya, which is thin insulating shell of radius 2r. Yes. Yan. Kuwari maganda drawing ko, guys. So, yung charge Q ay distributed raw sa insulating shell. Then, we are asked to find the electric field in each of the regions, 0 to R, R to 2R, and R greater than 2R. Okay. So, I think this is easy. This is R. This is 2R. Okay. Gagamit ka lang din ng Gauss's law kasi well, yung topic natin for today, Gauss's law examples. So therefore, you're gonna use Gauss's law. Pero, ayan, spherical naman yung system natin ngayon, so you can use Gauss's law. Okay? So, gagamit ka lang ng mga different Gaussian surface. So, may Gaussian surface ka dyan, dyan, and dyan. So, yung Gaussian surface mo ngayon would be a sphere. A sphere. Okay? And then, you'd always denote it as r. Small r. Okay? So, to do this, sulat natin para hindi tayo malito. Okay, for the region 0 to r, okay, between 0, bale, sa center, to the first radius, which is capital R, ayun yung solid, solid sphere mo. Solid conducting sphere. Therefore, without any calculations, you can say that E is 0. Okay? Again, this is a conducting sphere. Okay? I-compare natin siya sa, kapag insulating sphere, you can sprinkle the charge uniformly in it. Kaya, things are very different. Meron tayong example, I think. Ito. Ito yung example natin from last meeting na meron tayong positive electric charge Q distributed uniformly throughout the volume of an insulating sphere of radius R. So, ano yung implication nito? Yung implication nito would be, kunin mo yung percentage ng volume na na-cover ng Gaussian surface mo. Okay? So, we have here, ito yung E times your Gaussian surface, 4 pi R squared. Then, Q enclosed would change. Okay? So, kukunin mo yung percent volume. That would be simply dividing the partial volume over the total volume times the Q, times the total charge Q. Okay, so yun yung implication nun. However, if you're working with conductors, nasa outside surface lang lahat yung nasa surfaces lang yung mga charges mo. Okay? So that's the difference. Remember that difference. So for our case, since hindi mo pwedeng i-distribute yung charges in its volume, since it's a conductor, therefore wala ka ma-enclose na charge sa loob. Therefore, it's 0. Okay? Easy. So, pag may conductors, masaya tayo. Kasi 0-0 lang yung mga bagay-bagay. R within R and 2R. Capital R and 2R. Ito naman yung solve natin. Okay, so in this space, walang material. Therefore, we can get some field kasi may ma-enclose tayong charge. Okay? Mangyayari ay we do the Gauss's law, E times 4 pi R squared. Tama? Then what would be the enclosed charge? Kung titignan mo, ano ba yung nasa loob? Titignan natin, may positive charge Q doon sa conducting sphere mo. Therefore, ayun yung may enclose mo. Okay? Epsilon naught. And this is very easy kasi magiging E. Vector na natin. Q over 4 pi epsilon naught. R squared. Then R hat. Okay. Defined naman si ayan. Well, magbigay siya ng small r. Pero gets naman ko ano yung pinapoint out niyan. That r is the distance from the center. Okay, so this is the first one. Ano yung last na tanong? That would be r greater than 2r. So for that region, let's write them down. R greater than 2r. And then, usually, as usual, gagamit ka lang ng Gauss's law for pi r squared pa rin. Then you would need to look at the charge enclosed. So at the outside, makikita mo na yung solid sphere, and then the shell outside. Okay? Since yung shell mo, meron siyang charge Q, and yung solid sphere mo, meron siyang Q. Therefore, makikita mong charges would be 2Q. Therefore, this is 2Q over epsilon naught. Okay, sir, may tanong sa atin, sir, paano po yung extra na charge na nasa fraction of volume ng insulator na enclosed po for R within R and capital R to 2R? Hindi po ba additional charge na yun? Okay, yung yung system natin, ito lang yung mga system natin. Meron kang solid sphere, tapos meron kang thin shell. Okay, so inside here, walang material. Walang material dito. This is vacuum. Gets ba yung system? Ayun ba yung tanong mo kung bakit walang dito? Walang nakuha charge dito. Okay. Medyo nakakalito, no? Ito yung part na minsan mahirap sa physics. Yung pag nagbabasa tayo, minsan nakakalito siya. Lalo na pag hindi maganda gumamit ng words yung author. So, hindi natin kasalanan minsan, no? Minsan nakakalito lang talaga mag-construct ng sentence yung mga tao. Okay? So, baka mabengga tayo sa sentence construction. Ayan. Okay? So, yung insulator mo is a very thin shell. Parang eggshell lang siya dito sa labas. Ayan siya. Ayan lang siya. So, in the space between them, walang laman. Okay? You can imagine this as an egg. Yung thin shell sa labas ay yung conductor. Tapos tinanggal mo lahat ng egg whites. Tinira mo yung egg yolk sa gitna. Parang ganun siya. Okay? Hindi ko alam paano siya naging concentric, pero ayun yung given na tanong sa atin. Pero paano siya na-suspend mid-air. Pero physics. Okay, and tuloy natin. This would be Q over 2 pi epsilon naught or squared. Okay, kinancel ko lang yung 4 dito at yung 2 doon. So therefore, we're left with 2 in the denominator. Of course, this is a vector. You just pop that in. Okay, we're done with the first question. Then next would be graph the electric field magnitude as a function of R. Okay, now be careful sa mga ganitong tanong na. Lalo na pag mag-graph. Kasi mapapansin mo, by just looking at it, sinong mas malaki. Di ba mukhang mas malaki itong pangalawa kasi over 2 lang siya. Over 2 lang siya, tapos ito over 4. So, by just looking at it, ito sa tingin mo yung ito yung sa tingin mo mas malaki. But that's not the case kasi yung R mo is a variable, tapos meron siyang restrictions. Ito, greater than 2R. Ito, from R to 2R lang. Okay? So, tingnan natin kung ano yung mga values na pwede nyo matanggap at the boundaries. Meron tayong boundaries na dalawa, R and 2R. Palit tayo ng color para signify that we're answering different things. Meron tayong R, 2R. Okay? And then, etong si una mo, itong unang sagot natin, let's try to plug in R and 2R. So that's Q over 4 pi epsilon naught R squared. Okay. And then the other one, I would just plug in 2R here. Q over 4 pi epsilon naught. Plug in mo yung 2R dyan, magkakaroon ka ng extra 4 r squared. Okay, 4r squared. Now for the other one, ito naman, pa-plug in mo na lang yung boundary niya, which is 2r. For the other one, 2r naman yung boundary niya lang. So, q over 2 pi epsilon naught. Tapos, 2r squared. Then this is q over 2 pi epsilon naught for r. Okay? Ngayon, pwede na natin sila pwede na natin sila itignan ng mas maayos, di ba? Ito over 8, ito over 16, ito over 4. Okay? So, kanina, tinignan natin, mukhang mas malaki lang to. Pero in essence, pag pinlock in mo yung mga values ng mga r niya, over 8 siya. Tapos, ito over 16. Mas maliit pala ito. Tapos, ito pinakamalaki. Okay? So, paano natin ito gagawin? Let's try to write this down as e prime. And then, I could write this down as 1/4 ng e prime. Kuha. Pinactor out ko lang yung 4 sa labas. Tapos, 4 pi epsilon naught r squared. So, that's your e prime. And this is just 1/2 e prime. Okay, now to graph this thing out. Let's try to do this. Okay. R. Tapos E prime. Now I can have, I can write this down easily. E prime, half ng E prime, 1/4 ng E prime. Something like this. E prime. This is 1/2 ng E prime. Makes sense naman, di medyo kalahati yan, di ba? Tapos this is the 1/4 of E prime. Okay. Now I have the boundaries are 0, capital R, then capital 2R. So I could have this one, R, 2R. Okay? Okay. So for 0 to R, mag-graph na tayo, no? So for 0 to R, I have electric field 0. So I graph that down. So this is your 0 mark. I have this. Okay? And then from sa R, pagdating natin sa R, ano mangyayari? Tatalon yung electric field mo to this value. And since nasa R tayo, ang value nun would be actually E prime. Okay? So for R, tatalon siya papunta ng E prime. Yun, no? Straight line, no? Okay. Then, yung E natin is in the form of 1 over R squared. So, feel ko, alam nyo naman mag-graph ng 1 over R squared na graph. So, something like this. Pero wait, hindi natin pala alam siya kung saan siya pupunta. Kung pupunta ba siya sa 1/2 E or 1/4 E prime. Okay, so graph muna natin, lagyan muna natin tuldok pagdating ng 2R. So pagdating ng 2R, ito pa rin yung ginagamit natin. Then, pupunta pala siya sa 1/4 E prime. Okay, so tutuldokan ko muna 1/4 E prime. Madali. Then, this is exponentially decreasing kasi 1 over R squared. And then after this part, ang mangyayari would be, we'll change equations kasi nasa ditong boundary na tayo. And then pag pinlog in mo yung 2R dito, we'll get this. which is just 1/2 of E prime. So tatalon siya ulit papunta dun sa 1/2 E prime, which is this guy. Then exponentially decreasing, or 1/r² decreasing. Okay. Wow, ganda ng drawing. First time, first time. Okay. So we have this graph. Okay? So sa mga electric field, talagang usual yung ganyan. Yung para puro discontinuity. Okay? So that is the graph. Alright. Alright. Next one would be this one. 22.39. But since medyo good mood tayo, kayo magsagot. Tapos, kung sino makakasagot, they will be given points, bonus points. Okay? So, tatlong tao yung makakakuha ng bonus points. Okay? Merong A, B, and C. Ay, joke, 4 pala. A, B, C, D. Okay? So, raise hand lang kayo pag tapos na kayo mag-solve. I'll give you 5 minutes to do this. Okay? So, go. You can now start. Raise hand kayo pag tapos nyo ng sagutan. So, yung system mo dito, long coaxial cable. Meron kang cylindrical conductor with radius A and an outer coaxial cylinder with radius B and outer radius C. Okay, so walang laman yung A and B. Yung A to B. Okay, 0 to A would be a cylindrical solid conductor. Then, may conductor ko ulit sa B to C. From A to B, walang laman. Ayan. Tapos yung inner cylinder mo, meron kang charge per unit length, lambda. Okay. Then yung unang tanong would be, any point between the cylinders, So you're gonna find the electric field at points between A and B. Then the second one would be asking the electric field outside the outer cylinder. So that's greater than C. Then C would be graphing. D would be finding the charge per unit length on the inner surface and on the outer surface of the outer cylinder. Okay? So 846. Tapos raise hand lang kayo. So bonus points to, you don't have to do this. I'm gonna do this after 846 kung tinatamad talaga kayo magsagot. Pero yeah. Bonus points for those who can answer. Wala pa nakasagot kahit letter A pan lang. Ano to, 4 na tao pwedeng manalo dito. So, isa lang sasagutan mo. Yes, yes, you have to assume na on the outer coaxial cylinder, uniformly distributed ang positive and negative charges. Sige, 1 minute pa. Sayang naman. Sayang bonus points. May nag-chat ng sagot. You have to raise hand, no? You have to raise hand if para makita kung tama ba yung sagot mo. Okay, so walang magre-raise hand. Okay, last call, last call. Okay, may nag-raise hand. Sandro, what's your answer? Anong sasagutan mo? A, B, C, D?
Ay yung sa A po ba ay lambda over 2 pi epsilon r.
Okay. Anong direction?
Radial direction.
Okay. Tama. Very good. May bonus points ka. Okay. So, yung bonus points na to mapupunta sa prob set. Kasi may prob set kayo. So, pwede lang magpas yung score nyo. No? Sa prob set. So, kung wari, ito si Crisandra, may plus na siya. Plus na perfect niya pa yung prob sets. Hindi nagpas na yung prob sets niya. Mapupunta na yun sa exams. Okay, let's solve this Let's solve this example. Very good. Thank you, thank you. Ayan. For A, ang gagawin natin would be at any point between the cylinders at the distance r from the axis. Meron kang di ba? Meron tayong kung titingnan natin yung axis view, this is your solid sphere. And then you have a shell from B to C. Conducting shell. So this is solid also. Okay? Okay. So, ang tinatanong sa atin sa A would be finding the electric field in this point, in this space. So, that's A to B. So, A for R within A and B, ang gagawin natin would be, of course, this is cylindrical in nature. Therefore, we are free to use Gauss's law. And by Gauss's law, ang pwede mo ilagay na Gaussian surface would be cylinder. And that cylinder is just 2 pi r, then times the length. Arbitrary length, arbitrary r. But your r is forced to be in between A and B. Then the charge enclosed would be simply lambda times L. Kasi binigay sa atin si lambda. Yung inner cylinder daw, meron siyang positive charge per unit length. Charge per unit length. So you have to just multiply it by length V charge. Therefore, this is lambda L over Tama. Epsilon naught. Then, E must be lambda. Sinolve natin kanina. 2 pi epsilon r. Magka-cancel lang yung L. Then, yung direction would be r hat. Simple as that. Sayang, di kayo nagsagot ng plus prob sets niyo. Okay. So, next would be at any point outside the outer cylinder. At any point outside the cylinder, so our Gaussian surface would be here. Tapos, ayan, may cylinder pa rin. So, therefore, R greater than C. Tama, di ba? Hanggang C lang yung outer cylinder. Okay, tama. So, similarly, ganun pa rin yung Gaussian cylinder mo. Gaussian surface mo, 2 pi RL. Then, the charge enclosed is still the same. Kasi yung outer cylinder mo, sabi dito, wala siyang net charge. Net charge. So wala siyang dagdag, wala siyang bag. So, ito lang pa rin yung pag nag-enclose ka ng malaking Gaussian surface, yung na-enclose mong charge would be still yung lambda times length. Kasi ito walang ambag. Yung outer cylinder, wala siyang ambag. Okay? So, with that, lambda L pa rin yung mo. Epsilon naught. Then E must be lambda over 2 pi epsilon naught R per hat vector. Okay. Same lang yung sagot for A and B. Yes. Then, graph the magnitude of the electric field as a function of the distance R from the axis of the cable. Okay, so yung R from the axis of the cable. And then 0 to 2C. Okay. So simply, okay, so A, B, C, hanggang 2C daw, arte niya eh. 2C. ABC lang naman yung mahalaga. Okay. From 0 to A, ano yung electric field natin? Conductor with radius A. So in this region, from 0 to A, therefore it is 0. So we draw a line here. This is 0 siya. Okay, this is, sorry, hindi ko nalagyan ng electric field. It's a function of the radius. And then I just have here, which is lambda over 2 pi epsilon naught A. Pinlog in ko lang yung A. Wala lang. Then, tatalon siya from that value to this value. Tapos, from B to C, solid conductor na naman yan. Okay, solid conductor na naman yun. From yung outer coaxial cylinder is a conductor din. Therefore, my electric field would become 0 again at that point. Okay? So, lagyan ulit natin ng value. So, this is lambda over 2 pi epsilon B. Then, let's have another one for C. Lambda over 2 pi epsilon naught C. Okay? Ang nangyayari, tutuloy lang din yung electric field mo after C. Kung nakalabas ka na dun sa outer cylinder. Then it would be exponentially decreasing. Yan. So, ganyan. It extends to infinity. So, ito yung graph ng field mo. Okay, nice. Any questions? Okay, wala naman. Then lastly, ang tanong sa atin, ito medyo mahirap yung last na tanong. Okay, find the charge per unit length on the inner surface and on the outer surface of the outer cylinder. So we are asked kung, wait me lang tanong. Sir, hindi po ba insulator ang nasa in between ng BNC po since mounted on insulating supports daw po? Okay. Yung outer cylinder is still a conductor pero sinabi lang yung the outer cylinder is mounted on insulating supports. Sinabi yan kasi you don't want your charge to go somewhere else. Okay? Kasi kunyari, merong a harder version of the problem here. Ang mangyayari, kakabitan mo siya ng ground, which is a conductor, that is attached to the ground, yes. Okay. Merong harder version ng problem na to. Ang mangyayari, pag kinabitan mo kasi siya sinuportan mo siya ng conductor, yung induced charges sa kanya would go somewhere else. And we don't want that. Okay? Kaya lang sinabi na mounted on insulating supports para masabi that the charges reside only on the outer cylinder. Okay? Okay. Kunyari, kung naaalala nyo yung charging by induction. Kunyari, may ball ka ng charge. So, this is a conductor, no? Yung green mo. Tapos, imamount mo siya sa insulating support. Yung blue ay insulator. Then, you get a material that is positively charged. Okay? So, ang mangyayari dyan, syempre, ma-attract sa kanya yung negative charges. Tapos, mare-repel yung positive charges on the other side. Okay? And then, what you can do is attach a metal and connect it to the ground. And what happens next is that hihigupin lahat nung positive charges to the ground. Oh my God, that's so scary. Gumana yung Google. Nagulat ako, may nagsasalita dito. Anyway, mangyari is that so after some time, di-disconnect mo siya. Ang mangyayari, your sphere will become negatively charged. So, ayan. Okay? So, ayun yung essence, ayun yung sense nung ayun yung sense nung paglalagay niya ng statement na yun. Okay? Now, yung next problem natin would be finding the charge per unit length on the inner surface and the outer surface of the outer cylinder. Now, we know that the outer cylinder has no net charge, pero it can have charges on the inner surface and the outer surface of the cylinder. How do we do that? Gauss's law pa rin. Okay? So, to do that, diba, drawing ulit natin itong system natin para malinaw-linaw. Yes. Medyo lakihan natin yung regions from B to C. Okay, so this is solid. What you want to do is to put a Gaussian surface here, which is a cylinder pa rin. Gawin natin. E 2 pi r L must be equal to charge enclosed, Q enclosed over epsilon naught. But what is Q enclosed inside a cylinder? Inside a conductor, sorry. Subog na subog. Okay, inside the cylinder, Kahit anong mangyari, wala kang may enclosed na charge, it would become 0. Okay? So, hindi naman useful yung ginawa natin. Okay, pwede ito maging useful, okay? Sulat natin siya in terms sa mga makikita natin. We know exactly that the solid cylinder inside, meron siyang lambda L, di ba? Meron siyang lambda L na charge. And then, tapos let's say that i-add mo yung makikita mong charge doon sa inner surface, which is B, QB. Okay? Itong inner surface na ito. Ito yung pink na to. So, lahat sila pink. Pero ito kasi ay solid na. Ito yung inner surface nung outer cylinder. Drawing nga natin. Solid sphere. Solid sphere tuloy. Solid cylinder. And this is your outer cylinder. Hindi ako nalilito. Cylinder. Okay. Okay. So I could write this down as like something like this. Pero as prescribed by the properties of the conductor, dapat 0 tong numerator. So for this to be 0, therefore, QB must be lambda L minus lambda L. Also, epsilon naught. For it to become 0. Tama ba? Therefore, the charge per unit length on the inner surface must be negative lambda. Okay? Negative lambda. Si QB yung charges on the inner surface. Okay? So, charges on the inner surface, si QB, which is this in this part. Then, sa outer surface, we do the same. Sa outer surface, Gauss's law lang ulit tayo. E, 2 pi RL. Then, what would be the charges that I will be seeing? Ano makikita ko? Ano may enclose ko? Still, that would be lambda L over epsilon naught. As before. Wala namang bago for now. Lambda L over epsilon naught. Ito yung kanina. R greater than C. We're outside. Pero, now we have to consider, pwede natin isipin kung ano yung mga contributions sa charges ng inner surface, QB. Tapos, QC. Okay? So, si QB, alam na natin si QB, di ba? Negative lambda L. So, this is lambda L, negative lambda L. Yes. Lambda L plus QC over epsilon naught. Tapos, from here, makikita natin kung ano laman ni QC. Okay? Kasi alam mo yung final answer mo would be this one. Therefore, kung 0 na to, dapat lambda L na to. Okay? So, QC must be equal to lambda L. Therefore, the charge distribution for the outer surface of the outer cylinder must be lambda. Okay? And we have to evaluate our answer at B. Meron siyang negative lambda. At C, meron siyang positive lambda. Ano yung inscription natin? Ano yung sinabi sa atin? The outer cylinder has no net charge. Net charge, which is the total charge. So, kung i-add mo yung charge densities nila, 0. Okay? Tama yung sagot natin. Okay, kaya pa ba? Kaya pa bang physics? Okay. So, ayun, at I guess that's it for, okay, dalawa. Tama. Kala ko isa lang yung nabigay kong prop set. So, meron kayong prop set. This one to 22.54 and 22.48. Okay, can you do it by pair? Yes, sige. By pair, pwede. Optional lang by pair. Pwede kayo mag-by pair. Pero again, I would remind you that a lot of students, yung sa iba kong students na bumababa yung score nila sa exam dahil ayun, hindi nila nagagawa lahat ng project. Meaning na nagagawa ng lahat ng project, hindi nila nagagawa by hand. Okay? Kasi they were just helping their partner, their pair. Hindi nila na-experience yung magsulat and mag-solve ng the actual problem. So, ayan. Just a reminder. Okay, now I know some of you can find the answers here from the internet or whatsoever. Okay? So, yung pag-check ko ng prob set would be depending on your explanations, yung mga words yung nagagamitin. Okay? Okay, so hindi pwede yung puro ganito lang na ginagawa ko na puro ibabagsak mo yung Gauss's law and then you're done. Okay? So you have to explain what you're doing, what you want to do. Ako kasi nag-explain na ako by my voice kaya syempre hindi ko nasusulat. That would be redundant. Pero kayo kasi ay magagawa ng concept. Therefore, I want to see why things are. The deadline would be next meeting. Okay, next meeting. Okay, hello po, random question lang po. Pero bakit yung convention sa pagsagot hindi in terms of K and U expression? Okay, yung submission would be, paano yung submission? Okay, magagawa ko ng submission module sa Canvas. And then you have to upload your answers there. I-scan nyo siya. I-scan nyo yung papel nyo. Okay? So kung dalawa kayo, dapat makita ko sa papel nyo na yung mga pangalan. And then you have to scan it. Marami tayong scanning apps. Scanning apps sa mobile phones natin. Adobe Scan, free yun. And other scanning. Yung OneNote, meron din siyang pan-scan. Okay? You have to make it into a PDF. Tapos, submit nyo dun sa submission module na ipopost ko. Okay? Okay. Going back to the question, bakit hindi po ginagamit? Ang tanong mo ba ay bakit hindi ginagamit yung K sa mga expression? Okay. Bakit siya hindi ginagamit? Matter of preference. Minsan kasi mas madali gumamit ng for this part, kuwari Gauss's law, hindi mo makikita agad kung nasaan yung K. Okay? Kuwari yung pag cylindrical ka, mahirap makita agad kung nasaan yung K kasi 2 pi r yung gamit mo. Sa final na sagot, it doesn't matter naman kung yung paggamit ng K is a matter of brevity para mas maikli yung sulat mo. But yeah, you can use it if you want. Okay. Kuwari dito sa where's my pen? My pen is missing. Okay, here. Okay, let's try it this part. What would be this in terms of k? Yung k natin would be 1 over 4 pi epsilon naught. Therefore, E must be equal to also to 2k lambda over r, r hat. Okay, pwede mo sulat ng ganyan. And hindi ko kayo mamaliin. Okay, kung gusto nyo ganyan yung sagot niya. I would understand. Okay, lamang siya ng isang letra. Walang pi dun sa ano, walang pi dito. Okay, pwede nyo gawin. No, walang problema. Pero, ayun, that's an extra step. Useful yung K sa ano, useful yung K dun sa electric field ng ano ng charges, ganyan, between two charges na hindi mo kailangan ng Gauss's law. Okay? Okay. Anything else? Any more questions, guys? Okay. Kung wala na, stop sharing.